Okay, a very good morning, everyone, and welcome to yet another HSMA training day. So today marks the third and final of the kind of Python programming introductory trilogy, where we're basically trying to teach you as much sort of fundamental Python as we can within 3 sessions, which isn't particularly doable. So we try to go through most of the basics more than anything else. So as I've mentioned before, the purpose of this introductory stuff is really to give you enough information that you're able to start writing Python code. You'll get lots more practice on the kind of specific things that you're going to be doing. So next week, you're actually going to start putting all of these new skills into use and practicing your Python skills and getting to the real fun stuff, which is actually using all this these newfound Python skills in order to build models and build machine learning algorithms and all sorts of fancy stuff that we talked right at the very start of the program about all this wonderful stuff you can do. Now we've taught you sort of the basics and fundamentals of how to code in Python. You'll be able to do this. So today, as I say, is the last bit of sort of mopping up some of the other big things in Python that we haven't covered yet. So in the first session, we talked about some of the basics like conditional logic and inputs and outputs and loops and all that sort of thing. And then last week, we talked about a few different things, including functions primarily, and also things like exception handling. And of course, in the afternoon, we talked about 2 very important scientific packages for Python, which is NumPy and Pandas, which you'll be using a lot. So with that in mind, and as with last week, I'm going to start you off with a bit of a warm-up exercise just to get our coding muscles flexed. So you're going to start with this group exercise. I want you to work on this one as a group. So I want you to talk about how you're going to approach this and then have a go at coding this exercise. So with the materials for today, you'll have this Jupyter Notebook, Python Prog Workbook 6. Remember, you can open that in either Jupyter Lab or you can upload it to Google Colab if you prefer, or if you can't use Jupyter Lab. Let's just have a quick look at what the exercise is going to ask you to do here. So it's going to get you to write a little program here that involves classifying prime numbers with a few little twists on it too. So what I want you to do is have a look through this, read through it as a group, and before you start coding anything, I want you to throw around some ideas and start talking to each other about how you're going to approach this problem and design the program, and then have a go at coding it. So you've got until 10:15, so you've got 40 minutes. So I'm going to put you into your breakout rooms now. And yeah, have fun with this. You're going to need some of the skills you learned last week, in particular, around functions, and NumPy and Pandas, and that sort of stuff. So bear in mind what you learned last week. Maybe have your notes to hand as well, and have a little practice session on a little useful program. Okay, I'm going to stop sharing and I will open up the groups. Everyone, okay, I think we're all back now. So looks like you had fun with that. It's a little bit more tricky than the warm-up exercise I set you last week, and that's kind of why I suggested sort of talking about how you might approach the problem first, particularly as there's lots of little important little details that you need to put into this. So don't worry if you struggled a bit with that. I'm going to show you the solution now, or a solution. You may have approached it in a different way. I mean, that's fine. And as ever, I'll share these solutions after the session too. But if you didn't quite finish, it might be worth someone going back to it and tackling it again, because it's a nice little exercise just to get you thinking about writing and running a function. So let me just share my screen. Okay, and then let's go to the solution. Right, so basically you had to build this prime number checker and then call it and then basically record the numbers that the user input along with whether they were prime numbers or not. So the first thing I'm going to need to do is my imports. So here I'm going to need pandas for storing the results in the data frame. So I've imported pandas using the common pandas alias PD. So I can now refer to it as PD throughout. Then I'm going to write my function. Now, I've called my function here prime checker, which I think I asked you to do. Yeah. Now, remember, when we write this function here, nothing will happen. It's just telling Python that it needs to remember that whenever I say I want you to run the prime checker function, this is the stuff, the bundle of stuff that I want you to do. So my prime checker function is going to take an input, and that's basically going to be the number that you're going to check to see whether it's a prime number or not. Now, I noticed as I was sort of bouncing around the groups, a number of you picked up on this. What if the user inputs the number 1? Because very often you were checking for number 2. Well, we can deal with that separately. So if the user inputs the number 1, the number 1 is not a prime number. And is a special case, and therefore we'll deal with that separately. So if they put in 1, or let's just cover our bases and say if they put in anything less than 1, we'll come back to 0 in a moment, then we'll just return false straight away that it's not a prime number. Else, and here's where we get into the meaty bits, they've now input a number of 2 or more. So what we're going to do here is have a little for loop. And the range of that for loop is going to go from the number 2 all the way up to whatever number they have input. And again, I'll come back to that in a second. So we're going to use our good friend, the Modulus Operator, which, as you're probably seeing, is actually really useful for a lot of stuff in Python. What we're basically wanting to do is go through and see if there are any numbers that divide equally into the whatever number the user has input. If we get all the way through and we don't find anything, then we know it's a prime number. Because remember, the range in the for loop won't go up to whatever number we put in here. So it won't include the input number. Because obviously if it did, then it would be divisible by the input number. What we're only going up to, but not including the input number. And so therefore what we can do here is we can check for each value of I from the value of 2 up to whatever they've put in, but not including it. We can take the input number and take a modulus against I and see if it returns 0, i.e. is there a 0 remainder? Does it divide equally into that number? If it does, then it can't be a prime number, and therefore we can immediately return false. We can exit the function at that point and say, right, it can't be a prime number. We found a number that it divides equally into. However, if we get all the way through that loop and that conditional logic is never called because we don't find a number that divides equally into it, then it must be a prime number, and therefore at that point we can return true. So essentially what we're doing is we're checking first if it's the number 1. If so, it's not a prime number. Otherwise, we're then going to go through from the number 2 all the way up to, but not including whatever number was input, and take the modulus, take the input number modulus, whatever the increment we're up to, and see if it divides equally into that number. If it does, then it can't be a prime number. But if we get all the way through that loop and we don't end up returning false, then it must be a prime number at that point. We can be sure. Now, the reason I gave you this little hint here, so if you put in, if the user were to put in the number 2, which obviously is a prime number, then what will happen is this statement here will read for I in range 2 to 2. Now, where you've got a for loop, where you've got the same number, the same value for the lower end and the upper end, it will never run that for loop, because remember, it doesn't include this top value. So that for loop will never run, and in that case, it'll just go straight here and say return true. So return a true value for the number 2, which is obviously correct. 2 is a prime number. So it just needs a little bit of thinking. There are other ways in which you can do this, but I really just wanted to get you to think about how you might sort of break down the logic of this. But basically what we're doing here is setting up this function that goes through and checks to see whether there are numbers that divide equally into it. And if there are, then at that point we can say, no, it's not a prime number. But if we can't find anything, then we can declare it to be a prime number. So that's the function written, but obviously that won't do anything. That just tells Python that this is what we wanted to do when we want to check a prime number. So here down below, I'm going to do all the extra little bits I asked you to do. So I'm going to set up a new data frame, pandas data frame, in which I can store the results. I've just called mine prime df. You can call it whatever you like. And I'm also just going to record, because I asked you to record the run number in the data frame as well. I'm just going to start mine at 1. You might have started it at 0. You might have called it something different. I've just called mine run number for clarity. And then basically, I'm going to ask the user to input some numbers, and I'll check if the number is prime or not using the function I've just written up here. And I'm going to continue doing that until the user inputs a value of 0. So I'm going to put this in an infinite loop. So remember, we talked about where you want to cases where you want to have a deliberate infinite loop. So the while true statement creates a deliberate infinite loop. That just basically means while true is true, which true is always true, and therefore this will carry on indefinitely. Now, the first thing we're going to do is some exception handling, because it's a user input and they might input something that isn't a number, for example. It's going to be the biggest problem. So we're going to use a try except statement. We're going to try all of this, but if it fails at any point, then we'll just print a little message saying that it has to be an integer and please try again. And of course, because we're in an infinite loop, it'll automatically then go back round and try again. So the thing it's going to try is it's going to put a message to the user saying please input an integer and the number 0 if they want to exit, and it's going to capture that input, cast it as an integer, and then store it in this variable value here called number to test. So then we check whatever input they've made. Remember, if they put a string in here at this point, it'll collapse because it won't be able to cast it as an integer, at which point the except statement will be run, this message will be displayed, and it'll go back round again. But assuming they've input something valid, then it'll first check if they've input the number 0, because if they have, that means they want to exit. They no longer want to check prime numbers for the rest of their lives. And so we can break. So here I just print out the data frame. So it's got a record of everything they've done up to that point, if they've done anything at all. And I use the break statement, which will get me out of this infinite loop. However, if they haven't input 0, but they have input something valid, then they must have input a number that we can cast as an integer that isn't 0. And so we will go through this process here. So the first thing I'm going to do is I'm going to call the function that I've written up here, which I've called prime checker, and I'm going to pass in whatever number the user input, which remember we stored here in the variable number to test. So I'm going to call prime checker with number to test. Remember, that's the input. We said we needed an input number. That's what it's going to be working with in that function. And then the result of that, remember, is going to be a Boolean, because this function returns a Boolean value. It'll either return false if the number isn't prime, or return true if it is. So because it's returning an output, we need to store that in a variable value. So I've just called my variable here, is it prime, to indicate that it's a kind of a Boolean. So it'll call prime checker with the input number. It'll store true or false depending on what comes out in this value here. Is it prime? And then we can check and print an appropriate message to the user depending on what came out of the function. So if is it prime is set to true, in other words, the function declared that it is a prime number, then we'll print this message that whatever number they gave it is a prime number. Otherwise, we'll print that it's not a prime number. And then what I'm going to do, I'm going to set up a new temporary data frame so I can add to my existing data frame. Remember, we talked about how to do that last week. So I'm just going to call mine df2, and I'm going to set up a new Panda data frame. I'm going to set the run number to be the run number, which remember was set to 1. So the first time we go through this, it'll be have a run number of 1. Tested number will be whatever number was input by the user, the number to test. And then whether it's prime or not, I can just grab from my Boolean value here. So I set that up. I set the index to be the run number to match the data frame that I'm joining into. And then I add the df2, the new temporary data frame, to my main data frame prime df. And that will add it. So each time it'll go through, assuming they input something valid, it will go through and it'll add the run number, the tested number, and the prime Boolean to that data frame. And then, of course, the last thing I want to do is increment the run number by 1. So the next time we go through, it'll now be on run number 2. So then if the user inputs something valid again, then it'll store this against run number 2. And as I say, if anything falls over at any point here, it'll run the exception. So let's just try this. If I run this here, so let's input an integer. Let's try the number 1. 1 is not a prime number. Great. The number 2 should be though. Let's input 2. 2 is a prime number. Fantastic. Let's try 4. 4 is not a prime number. It's 5. Yes, 5 is. And I can keep going. And as soon as I push 0 and hit enter, it'll exit and it'll tell me all the things I've tried. So the run number 1, I tested the number 1, and that was not a prime number. Run number 2, I tested number 2, that was a prime number, etc., etc. It's a simple little program, but just getting you to use the functions and pandas data frames, and again using this sort of forced infinite loop to make sure that the user inputs something you want them to. Any questions about any of that?
Hi, yeah, can I just want to touch on to one where I had an issue where appending, running the function by itself returned a Boolean, but when I was appending it to the data frame, it came back as a 0 or 1, and I couldn't get it to show true or false. Is that an issue that makes sense?
It's odd. I'm not sure why it's doing that. So if you're as long as you're returning a Boolean value with the sort of capital letters on the true or false, then that should keep it in that format. So I'm not sure why that is. If you post the code, I'll have a look, see if I can see anything obvious on that.
Okay, thanks. It's in our PSG file. You can look.
Fantastic. Okay, I'll take a little bit of a next step break. Fantastic. Any other questions? Let's move on then. But as I say, do that. If you didn't manage to finish that off, do have a look at the solution and have another stab at that. Oh, sorry, got another question, Victor.
Hi, this is just a general coding question, but is there any way to auto indent code in Jupyter Lab?
It should automatically. Let me try something a moment. It should. Let's have a look. Yeah, it should automatically indent if you've set up the same way as in Spider. I thought it should. Is it not doing that for you?
I know it does, but I'm saying manually editing code, and sometimes the indentations are out of place. So I was just wondering if there's any way to apply it to the whole script.
So so when you're typing normally, if it's expecting an indentation, then Jupyter Lab, along with most IDEs, will automatically indent this. If I start typing, it'll automatically pick up that's an indentation. If you want to shift things over or back, and something that I mentioned to a couple of the groups last time, but I don't think I've mentioned it. I probably should have mentioned this before. So if you need to shift lots of code all in one go by an indentation, then you can just highlight all the code you want, and you can either hit tab to move it over to the right, or shift and tab to move it over to the left. So that's a really handy little tip if you need to shift blocks of code all in one go. Let's move on to the start of the object-oriented programming lecture, so the meat of this morning. So we're going to talk about object-oriented programming. Now, we talked briefly about object-oriented programming in the Principles of Programming session back on the first day. And I said to you that actually object-oriented programming is the preferred way in which you should code. It's good practice to write stuff, particularly if you're doing anything non-trivial. So if you're doing, you know, sort of odd little bits of code here and there just to test something out, or just writing a simple little program, then you may not need it. It might be overkill. But generally speaking, when you're developing something, and particularly for your projects, you're going to want to be thinking about developing in an object-oriented way. And indeed, many of the modeling methods that I'm going to show you in this course will use an object-oriented structure. So the agent-based simulation stuff that we use, a package called Mesa, that's entirely object-oriented. So you set up the idea of agents, and they all have their own sort of methods and their own behaviors and attributes, etc. And so that lends itself very well to an object-oriented structure. But even things like SymPy. So next week, when I show you SymPy to build some discrete event simulations, I will start by showing you the non-object-oriented method, but later in the course, I'll then show you how to build, how to translate that into an object-oriented framework, which is a much better way of doing things. But let's just remind ourselves what we mean, first of all, when we talk about object-oriented programming. So, object-oriented programming is a way in which you code in which everything is thought of as an object. And so we have this idea of classes, and classes contain kind of the blueprint, the general blueprint of what one of these things should look like. And that class will contain attributes, which are basically variable values, and methods, which are things that this object can do. And so the general description is known as the class. And then what we do is whenever we want to create an instance of this class, that we can use, we use a process called instantiation, and we say, okay, I want one of these things now, I want to create one of these things, and then we can use that object, and we can create lots of these copies of these objects. So it's a bit like, think of it, you know, you're sort of creating a Frankenstein's monster each time, and you've got your little recipe for how you're going to build your Frankenstein's monster. That's in your class, and then you say, okay, I want to create one now. And then you bring one into being, and that's the object. And the object is the thing that you work with. You don't generally work directly with the class. The class is just there to describe what one of these things should look like, but then you create objects from these blueprints, from these classes. So here we have the example we had last time. We've got an example class called a vehicle. These have attributes such as common name, which might be a string, number of wheels, an integer, etc., and various methods. I've just got one method here to drive at a certain speed, and then I can create objects from that. So I can create an instance of vehicle that has a common name of ambulance, for example, and has 4 wheels and a capacity of 3, etc., or one with a common name of bicycle and has 2 wheels, etc. And then thinking of something more relevant to many of you, so you might have a class that describes what a patient looks like. And a patient may have a name which might be stored as a string, patient ID is an integer, age is an integer, you probably store date of birth, not age, but just for simplicity. And these are all the attributes, and then it may have, each patient may have certain methods, like it may attend ED or receive treatment. So again, this contains the generalized blueprint. And then whenever we want to create a new patient in our model, then we can create an instance of this class, which is known as an object. And then we can bring this into being from this blueprint. So we're creating our Frankenstein's monster. This one's called Bob Jones, and it's got this patient ID, and he's 64. This one's called Mary Smith, etc. And we can then deal with those objects separately. but we can create these objects, as many as we want, really easily from this blueprint. So we only have to define the blueprint once, and then we can deal with these objects separately. And this is really useful, particularly when you're modeling, as you can imagine. And today you're going to move slightly closer to the sort of modeling stuff I'm going to show you next week. In terms of, you can deal with these sort of these patient separate objects separately and create them just from this generalized blueprint. Now, remember, we also said, we talked about something called a constructor. So the constructor is basically a method within the class that puts together an object. It's the thing that when you instantiate from a class to create an object, it's the thing that tells it how to put one of these things together. It's your Frankenstein to create your Frankenstein's monster. It's how are you going to create this thing? So it constructs the object. It will set up all the initial values for the attributes, and it will set up all the methods, and it will bring this object into being from the class description. So let's have a look at what this would look like in Python. This is how we would set up a simple class in an object-oriented framework in Python. So the way we do this, first of all, we define a class by using the class keyword here. So whereas for functions, we use the def keyword. With classes, we use the class keyword. And then we name the class, and we can call it whatever we like. But we must ensure that we use capital letters, or capital letter at the start at the very least. And good practice should be that you use a capital letter for each new word, even if you're using the sort of underscore separation method. So I've called my class here just for simplicity. And then we use the colon, and then of course we'll get an indentation. And then everything in this indentation is basically our class definition. This is our blueprint for what one of these objects should look like. So the first thing we usually put into a class is what are known as class attributes. These are basically variable values that will all have the same value for any instance that will be created from this class. We don't tend to use this very often because you can also put them, set them up in the constructor in that way, and that's probably the preferred method. But I'm flagging that up because you may sometimes see that. But here are the key things that you'll typically see when you set up your classes. And the first is defining the constructor. So remember that thing that's going to put together our objects. Now the constructor method is named init for sort of initialize. And this is, you'll notice that there are, hopefully you can see this, there are 2 underscores both before and after init. And this is what's known as a dunder method. And dunder basically stands for double underscore. And they're also known as magic methods in Python. I'm not going to go into detail about what these things are, but basically they're methods that you don't have to call manually. They're automatically called whenever the time is right. So in the case of the constructor here, this will automatically be called when you say, I want to now create an instance of my class. The constructor method will be called automatically. And so that's why they're known as these magic methods or dunder methods. But you must call your constructor underscore underscore init underscore underscore. Okay. So we need to pass in some parameter values to the constructor, and primarily these are the things that we need to feed in so that it can set up the attributes for this particular class. The first thing, though, we always have to pass in, even if we've got nothing else to pass in, is this keyword called self. Now, the self keyword is basically, again, a little bit complex, but what the self parameter does, basically it stores the copy of the class. So when you create an instance of my class, you'll be then dealing with the object, so that you'll have a separate instance of my class. And self is the thing that stores that instantiation. It stores that copy, if you like. Okay. So then you can refer to self to say, I'm referring to me. I'm that Frankenstein's monster that you created from that blueprint. Okay, so you always have to have the self keyword as the first input parameter here. And that's the thing that's going to store the copy when you create an object from this class. And we'll see examples of that as we go on. So here I'm also passing in a couple of other attributes. I just call them attribute 1 and attribute 2. And then in the constructor, I'm basically going to assign these attribute values. So in this case here, I've got a couple of attributes. So these are parameter values, remember. And I'm going to store them against the class. Now remember, when we create an instance of this class, we basically want it stored against that instance. So we're referring to self here. So we say self dot attribute 1. In other words, store this input value here in attribute 1, or the attribute I've called attribute 1, and that is stored in the copy that I'm talking about. So the copy that I've created, the object, the specific object that I've created from the class description. So that's where I need you to store it. If we didn't do that, it would just store it in the class, and that's no good. We're not working with the class, we're working with the object. So all classes have to have a constructor. But of course, they may also have other methods as well as the constructor, and very often they will. Now, for any other methods, these will just work in the same way as, so just to explain, we typically talk about methods rather than functions when we're talking about functions within a class. It's the same thing. So a method and a function is the same thing. It's just a method we typically use to refer to a function that sits within a class. So it's a method of an object, a function of an object, sorry. So we've got various functions here. We define those in exactly the same way that you are used to writing functions. The only difference is that regardless of whether or not there are other parameters that need to be input, you always have to have the self keyword as the first input parameter. Because basically what we're saying is whenever I call this method, I need to pass in the copy of the class that I've made, i.e. the object, in order to do that stuff on the object rather than the class. You'll get very used to very quickly when you're doing object-oriented programming in Python, this idea of you have to always include self first, and you have to refer to self dot whatever you're talking about. It will become sort of second nature once you get used to it. But yeah, just remember that you always have to pass in the self to say, because this isn't the thing that's, this will just create a new instance and a new object. But actually we need to pass in self to say that when we then talk about that particular object, that's where it's going to be stored. Okay, so that's a sort of abstract example. Let's have a look at a more concrete example to make that a bit more real, and probably make it a little less complicated as well. So let's think about how we might set up our vehicle class that we described before in Python. So we've got a class called vehicle. We've got 3 attributes that we want. We've got a common name, which will store as a string, a number of wheels, which will be an integer, and a capacity, which will be an integer. And then we've got 1 method that we want called drive, and that basically takes as an input a speed at which we want to drive. So we set up our class here. Remember, we use the class keyword. We give it our name here with a capital V here to indicate it's a class. So class vehicle. Then we use our colon. And everything here that's indented is part of this class blueprint. So the first thing we need to do is define the constructor using our dunder_init method. And into that constructor, I need to pass in anything that when I set it up, I'm going to need to pass it. So when I say I want a new vehicle, here's the information I need. You're going to need to create a new vehicle. Well, in this case, it's going to be the name, the number of wheels, and the capacity. So these are the things that the constructor is going to need to take as inputs, as well as the self keyword. So common name, number of wheels, and capacity. And then I'm going to store those things against myself, against the copy of myself that I just created. So I use the self keyword. So I say self.common_name equals common name. So whatever, when I create a new vehicle, here's the common name I want. the constructor will say, okay, I'm going to create a new vehicle. I'm going to store it in self, and it'll have a common name, and that's the common name I will give to self. Here's the number of wheels that I will give to self. Here's the capacity I will give to self. So that when it creates that copy, the object will have these values stored against it. So that's the constructor, but we also need to set up a method here called drive. So I've set up that method here. I define that in the same way as any other function that we write in Python, except we need to remember to pass in self first because it's a method of a class. But I also pass in speed for this one. And then I'm just going to have a very simple method that just prints a message saying I'm now driving at whatever the speed is miles per hour. Okay, so really simple. It's just you set up your class using your class keyword, give it a name, and then we set up our constructor here, which will basically show it how to assemble the attribute values, which we're going to pass in, the 3 attribute values. It'll then store that against the copy of the class, and then any other methods we want. So here, drive, and remember, we have to pass in self so that it can deal with the copy of the object and not the class itself. So once we've defined our vehicle class, in the same way as when you write a function in Python, nothing happens until you actually do something with it. All that you're doing is saying, so back here, all we've told Python is, I want a class called vehicle, and here's the constructor, here's how I want you to set up the attributes, and here's another method called drive. But nothing will happen with this until we tell it to create a vehicle from this blueprint. So we need to instantiate and create some objects if we want to actually use them. So how do we create an instance and object? Really easy in Python. So what we do is I'm going to give my object, my instantiated version of that class, a name. So I'm just going to call it my ambulance. This is going to be a copy of that class that I'm going to create. So this will be the object that I want to deal with. And then I give it the class name with the capital letter. And then in brackets, I need to put in the things it needs, which remember are the things we're passing into the constructor. You don't need to pass it self because it does it automatically, but we need to pass it the 3 things that we've set up here. So we've told it that when somebody wants to create a vehicle, it's going to be expecting a common name, a number of wheels, and a capacity. And so those are the 3 things I'm going to need to give it. So I'm giving it a common name of ambulance, number of wheels is 4, and passenger capacity of 3. So by running that line of code, it will create a copy of the vehicle class with common name ambulance. It has an attribute that says it's got 4 wheels and a passenger capacity of 3. And I can now refer to that copy of the class by this word, by this name here, my ambulance. So that's now, my ambulance is now a copy, it's an object that I can work with, a copy of that blueprint. Now I've created that, I can do things with it. So we've got a method in that class called drive. I can tell my ambulance, my newly created ambulance here, to drive. So the way I do that is I give the name of my object, which I've just called my ambulance here, and then I use the dot notation to say I need to access an attribute or method associated with this object. And so I want to call the drive method within my object, which remember we've defined here. So my ambulance has this drive method in it that was constructed at the time. And I'm going to pass in a value of 60 because it needs to know the speed for this particular method. And if I call that, it will then print this message here. I'm now driving at 60 miles per hour because that's what the drive method does. Okay, but I've done that on a copy of this class. So it's not this class that's been called, it's a copy of it, an instantiated version of this class known as an object. And of course, the beauty of object-oriented programming is that this then allows us to create multiple objects from the same class. So we can just define the class description, the class blueprint once, and then we can just really easily create lots of different objects from that. So from that single class description, I can create Mike's ambulance, which is a vehicle which has a common name of ambulance, 4 wheels and passenger capacity of 3. I can create Sean's car, which is a separate instantiated instance of that class. It's a separate object, but built from the same blueprint, which is also a vehicle, but this one's got a common name of car, has 3 wheels and 2 passenger capacity of 2. Alison's bicycle, which is a bicycle that has 2 wheels and a capacity of 1, and Tom's monster truck, which has a common name of monster truck and 4 wheels and a capacity of 1. And so I've created all those 4 different objects that I can then treat and work with separately. And each time I only need this single line of code to set up one of these objects, because I've already set up the blueprint for what these things should look like. So let's say that we wanted to add an attribute called owner to the vehicle class, and that we want to have the whoever the owner is displayed in the message whenever the drive method is called. So I've added here to my constructor self.owner, and that will store the value of owner that's passed in here. So I've added that into the list of things that needs to be passed in. So now when I create a new vehicle object, I need to also pass it the owner, as well as those 3 things I passed it before. And I've just changed my drive method very slightly, so that now displays the message that the owner is now driving at whatever miles per hour. But the key thing here is that I need to refer to myself when I'm doing that, because remember, when that drive method is called, it'll be called not on the class, but on the object, on the copy of that class, on the that particular instantiation. And so when I need to refer to one of my own attributes that are stored against me, then I need to use the self keyword to say the variable value owner that I'm talking about here, that's the attribute I've got stored against myself. In other words, the one that was set up here in the constructor. Okay, so self.owner means it's a variable value that I'm holding. So imagine your object as kind of carrying around these pieces of information. We talked in the very first session about how variables are a bit like boxes that have names and pieces of information inside them. Imagine your objects as basically being little copies of these classes that carry around their boxes, and each of those boxes has a name and contains some information inside it. So here it's carrying around 4 boxes, has the common name, the number of wheels, the capacity, and the owner. And so when I want to refer to that, I need to use the self keyword to say, look inside your own box that you're carrying around. What's the value stored against owner? And so then I could set up in the same way I did before, Mike's ambulance, Sean's car, Alison's bicycle, and Tom's monster truck. And then I can call the drive method on each of those things with different speeds. So I can say Mike's ambulance.drive. That will call the drive method of the copy of this class that's stored within that particular object. As I told Mike to drive at 50 miles per hour, and it'll print this message here: Mike is now driving at 50 miles per hour, etc., etc. The same down here, same principle. So if I wanted to print a message saying Tom's vehicle has, and then I want to find out how many wheels Tom's vehicle has, I can use the object name. Remember, I've called Tom's vehicle Tom's monster truck, and then use the dot notation to access the number of wheels. So I can, whenever I give the name of that object, I then say dot, and then I can access any of the attributes stored against that object, or any of the methods stored against the object. In the same way, we use the dot notation. So here I want to access the number of wheels that are stored in Tom's monster truck. Okay. Now, just a small point worth pointing in. Not all of the attributes that have to be passed into the constructor externally. You could, for example, have an object that gets created where you have some default values, and there will always be those default values whenever you set up a new object. So, for example, here I've set up a class called student. I've set up my constructor. I'm passing in a variable called name, and that will be stored against my own attribute called name, and I'll use that value. But I may also have some other attributes where I don't need to be told when I need to create a new student this is the information you need, because it's going to default to these things. So I can just set them up here with some default value. So things like whether I completed the course may always default to false, because you haven't completed the course when you start as a new student. Here we are, sorry. Or the level at which you start at. So self.level, I've started at 1 here. So you don't have to pass in everything that you need. You may have some values that you set up in the constructor where you don't need to be, the constructor doesn't need to be told them, doesn't need to be passed those in when you're told it wants to create a new student. So in this example, when I want to create a new student, I've just called my student. That will create a new student object from this class. And I call the student class name here, and the only thing I need to pass in is the name. That's the only thing it's expecting, and that will then create a new student with the name Dan Chalk, and it'll automatically give me a completed course of false and a level of 1. But I don't need to pass that information in. The other sort of point related to this as well, the names of the parameters that you pass in don't have to match the names of the attributes in the class. So in the same way as when you write a method and you write the function definition and you say these are the names I'm going to refer to in this function, they don't have to match the names of the things that you're passing in when you call the function. They very often will, but they don't have to. But you, again, as with functions, you need to make sure that you're using the correct name internally. So here I've got the same thing. I've set up a student, but in this constructor I'm passing in the full name, date of birth, and a year. And I've called it full name, dob, and year here. So these are the things that I need to refer to say the values that were passed in when you you asked me to create a new student. But they may not match the names of the attributes that you want to store. So I may have an attribute called name that is going to store this full name thing here. I may have an attribute called date of birth, so that when I have my student object, it's actually got an attribute called date of birth, but the thing that's going to be stored in there is this thing here, dob, that was passed in. So they don't have to map, but they were. Okay, any questions about any of that?
Hello.
Hey.
Can you hear me? I'm not sure.
Yeah.
Can I ask a question there?
Yeah. Could we have multiple constructors with different number of parameters? So like constructor overloading.
You should always have just one single constructor that will define how to set up a particular object from that class. You may have conditional logic in your constructor, but you should always have a single constructor, and it needs to be named with the dunder method in it. So you only have a single constructor.
Thanks.
In which case, let's get you practicing doing some object-oriented programming. So what I want you to do, and I want you to do this in your group. So again, I want you to work in your groups for this. I want you to write a class definition in Python for the patient class that's outlined on this slide. So that's a class called patient, has these attributes: a name, which is a string, a patient ID, which is an integer, an age, which is an integer, and a Boolean value called cured, which has a default value of false, and which also has these two methods here: attend ed, which accepts as an input a mean time, and receive treatment, which accepts as an input a probability of cure. Now, this exercise is going to get you a little step closer to the sort of thing we're going to be looking at next week when we actually start building some models with all of this. So it's starting to get you to think about and get you used to the sort of things you're going to be doing. So I want you to write this class definition. Now, the attend ed method that you're going to write in this class, basically what I want this method to do is to randomly sample a time for the patient to remain in the ED from an exponential distribution based on whatever the mean time that gets passed to it when that method is called. And it then prints a message stating their name, their patient ID, and how long they were there. So it may randomly sample that they were there for 10 minutes. So it'll say, Dan Short, patient ID 247, stayed in the ED for 10 minutes. Now, to sample for an exponential distribution, we can use the expovariate function of the random library. So you'll need to import that. And you can call this function here. And you need to give, for the expovariate function, you need to give what's known as the lambda parameter. We'll come on to that a bit more when we look at SymPy, but for now, lambda is basically just 1 over the mean. It's the inverse of the mean. Okay, so whatever the mean value is, you take 1 over it, and that's the value you need to pass in. The receive treatment function, what that's going to do, I want you to get it to randomly determine basically whether the patient is cured, and the probability that they are cured is determined by a number between 0 and 1 that's passed into it. So this prob cure is a number between 0 and 1 that determines the probability that they are cured. So obviously if it's 0, they're never going to get cured. If it's 1, they'll always be cured, etc. Now, what I want you to do is to sample from a uniform distribution to determine if they're cured based on that probability. I want you to think about how you're going to do that. And you can sample from a uniform distribution, again, from the random library using the uniform method, and you just pass in 2 values, which are basically the number, the bottom and the top number, the range that you want to generate a random number. And remember, a uniform distribution, there's an equal chance of any number being sampled. So there's an equal chance that if the number's between 1 and 10, there's an equal chance that it's the value 8 is the number 2, for example. If the patient is cured, if you determine they are cured in this method, then their cured attribute, remember, which is a Boolean, is updated to true. When a new patient's created, it defaults to false. And therefore, you don't need to pass that in when you're creating a new patient, but it does need to be set up in the constructor. And then once you determine whether they're cured or not, you get the method to print a message to the user to tell them either way, were they cured or weren't they, along with the patient's details, their name, ID, and probability of cure. So once you've defined all of that, I want you to then, and you created your class, and you created your attributes, and you've written the methods as described here, I want you to create some instances of the patient class and call the attend ed and receive treatment methods to see what happens. You can either do that by writing some in your program, or you can have your program with just the class definition, then run the program, and then use the IPython console to then dynamically create on the fly some new patients and tell them to attend ED and receive treatment. However you want to do that, okay, or both. So I want you to work in your groups. A little bit more challenging, this exercise. I'm going to give you 45 minutes plus a 10-minute break as well. Well, actually, let's resume at 12. So slightly, about 7 minutes for a break. But you can either have a break now or have a break after. I'll probably have it now if I were you. But yeah, have a go at this in your groups and talk about this first, and make sure you're doing this as a group. This is a little bit more difficult, this particular exercise, but it will give you some good practice on how to do some object-oriented coding. Okay, I will stop there and I will open up breakout groups. Hello everyone, sorry, I think you should have got a 60-second warning. I think it sort of booted you all out unceremoniously, so apologies if that was the case. I'm not sure why I did that. I noticed everybody was sort of back in instantly. Okay, so I think from looking around, I think most of you got most of this, if not all of it. So I'm going to just spend a bit of time just going through the solution now. So let me share my screen. Okay, let's have a look at the solution. Okay, so first thing I'm going to do, I need to import my libraries as with any piece of code that we're doing, and I'm going to need the random library in this particular piece of code. First of all, my class definitions. I'm going to set up my class, and I've called my class patient. So I use the keyword class and then call it patient, and then use my colon, and then everything in here is the blueprint for the class. Now, the first thing we're going to do is set up the constructor. Remember, this is a dunder method, so I need to use double underscore both before and after the init word here. Now, the things I need to pass in, I need to pass in self, because I must always do that so that it can store the copy when I create new patients. And I'm going to need to pass in name, patient ID, and age. I don't need to pass in cured, because that's going to be an attribute that always defaults to false. So we're only passing in here things that we need to, when we create a new patient, that we need to specify. And obviously I don't need to specify that if it's always defaulting to false. So I just need name, patient ID, and age here. And then within the constructor, I will assign the attributes. So self.name, the attribute called name, stored against the copy of the object, will be whatever name values passed in here, the same with patient ID, and the same with age. And then I'm also going to create an attribute called cured, which will be stored again as an attribute of the patient object, but will have a value of false. So we're always going to default to false for this. Then I've got my methods. So I've got my attend ed method, which takes both self and also mean time that's going to be passed in, representing the mean time in ed. And all I'm going to do here is basically sample a time from the exponential distribution using this mean time. So I'm going to use random.expovariate to take a sample from an exponential distribution. And because that's expecting a lambda value, which is the inverse of the mean, then I need to give it as its input 1 over the mean. And then whatever sampled value we get, so we're basically taking the exponential distribution, we're setting it up with this mean, or rather this lambda value, and then it'll randomly sample from that distribution, and that will then be stored in this variable value here called time spent in ed. And then all I'm going to do is print a message saying how long they spent in ed. And here, so I'm using my f strings, I'm going to give the patient ID, which remember is stored against myself as the patient. So that's self.patient ID to access my own patient ID for this patient. The name, which again is stored as under self.name, and then how long I spent in the ED, which is what I've just calculated here. But I'm going to round that just to 1 decimal place. Remember, this notation we can use in our f strings here, where we can use the colon and then specify the precision. So 0.1f means a floating point number with a precision of 1 decimal place. And so that will round it nicely for us. And then the receive treatment a method, again, we pass in self because we always have to, as well as the probability that they're going to be cured. And so in this method, what I wanted you to do was try and work out how to use a random uniform distribution in order to use this probability here. So I think most people got this. If you think about a uniform distribution, there's an equal probability of anything in that distribution being selected. And that's really handy when we want to branch off and do different things. It's really handy for modeling, as you'll see next week when we come on to the SymPy stuff. So what we can do is we could say randomly pick a number between 0 and 1 and use the uniform distributions. There's an equal chance of any of those numbers being selected. And then we can check it, whatever number, against the probability that we've passed in. So let's imagine that the probability was 0.5, so 50-50 chance. That would mean that there's a 50%, if we take the random, the uniform distribution, take a random sample from a uniform distribution between 0 and 1, because everything is equally likely to be picked, that means there's a 50% chance that the numbers 0 to 0.5 will be picked, and there's a 50% chance that the numbers 0.5 to 1 will be picked. So in other words, the probability, it's like you're slicing up the values between 0 and 1, and there's a 50-50 chance of either of those, either a value that's less than 0.5 or greater than 0.5 being picked. And similarly, if you think about it, so let's imagine the probability of cure was just 0.2, so 20%, then there'd only be a 20%, only 20 values between 0 and 1 would fall less than 0.2. So therefore, there's a 20% chance that a random sample from a uniform distribution between 0 and 1 will pick a value between 0 and 0.2. So we can use this random sampling from a uniform distribution to pick a number that then compares against a probability to see whether something should happen or not. In this case, whether they get cured or not, which would make sense. Obviously, the probability of cure, if that was 100%, so a value of 1, then all of the values would fall below it, and so there'd be a 100% chance that you would pick a value that was less than probability of cure. So if that happens, we can just use a conditional logic here. So we just take our random sample from the uniform distribution, compare it against the probability of cure that's been passed in. If it's less than that, then we can say that they've been cured. Otherwise, they haven't. And then I've got another piece of conditional logic here that just sees whether they've been cured or not. If they have, then it prints a message saying they were cured with their attributes, patient ID, name, etc. And also prints out their probability of being cured. And just to make that friendly for the user, I've taken in the probability that they were cured, and I've just multiplied it by 100 and rounded it to 1 decimal place. If they weren't cured, then we essentially print the same message, but just say that they weren't cured, and this was their cure probability. Now, obviously, we don't use self.probCure because that isn't an attribute. The probability of cure isn't an attribute of the patient object. It's just something that was passed into this method. So we just refer to it as probCure, unlike the patient ID and the name and the age, and whether they were cured or not, which these are attributes of the object itself. And that's why we use the self keyword. So once we've got that set up, we can try out creating some patients. So here I'm just going to create 2 patients. I've just called patient 1 and patient 2. Patient 1's called Bob Smith, has this ID and is 61. Patient 2, Mary Jones, with this ID and is age 55. And then I'll try getting them to attend DD and receive treatment. So patient 1, Bob, he's going to attend DD with an average mean time of 60 minutes. And then we'll receive treatment with a 30% probability of being cured. And then Mary will attend DD with a mean time of 180 minutes, and will have an 80% chance of being cured. So Mary is certainly more likely to be cured than Bob, but this is random. So when I run this, maybe the other way around. We don't know. There's still a chance that Bob will be cured and that Mary won't be. So let's have a look. Let's run it, see what happens. Okay, so Bob was in ED for 20 minutes, so he was very lucky there. And he was cured. So even though there was only a 30% chance, he was actually cured. And then Mary was in ED for 0.7 minutes, which is quite extraordinarily low. And again, that's going to be your sort of random sample of something very unusual happened there. And she was cured. I'd like to see the doctor that cured her in 0.7 minutes, but there we are. This is obviously dummy data with yeah, unlikely to be very realistic. But hopefully that gives you an idea of how you can use object-oriented programming to create these classes, class definitions, and then create objects from that, and then use instantiation to create instances of those classes. Okay, any questions about any of that? Okay, you'll get lots of practice with object-oriented programming. Don't worry, it can be a little bit weird at first. It takes people a little while usually to get used to how to code in an object-oriented way. And it can... Oh, hello, sorry.
Hi, sorry. I just wanted to know why we have to put the inputs in for like the probability of so the probabilities, yeah, exactly. So the 0.3 or the 0.8 is like, would the next iteration of this be asking the user to input those? and how, I guess, between 0 and 1 is obvious because it's the probability of them being cured, but the attend ED, I'm not super clear on what kind of input you're looking for in order to make it make sense. Is that
yeah, I mean, the key thing to say here is this is not how you would actually code a model. So you'll see more realistic examples next week when we come to actually build these kinds of models using the SymPy framework. So normally what you would have, there would be, what you may have in reality would be a certain probability of, you know, somebody being cured depending on the condition they had and their age and all sorts of other things. You'd probably have a sort of lookup table for that, and then you would draw that in. So yeah, this is just to get used to creating an object from a class descriptor, that's all.
okay? That makes sense. Thank you.
I have a question as well. It's the random.uniform. I put in a probability of cure of 0, and it still said cured, and I'm just wondering if it's pulling out something weird.
Something weird. It shouldn't. If you've got it set up that the random uniform distribution picks a number between 0 and 1, and you're checking if it's less, unless you have less than or equal to, that would cause it. It needs to be less than. So it may be worth just double checking your code, because the random uniform sampling should only generate a number between, well, it'll actually generate a number between 0, it won't include 1. That doesn't matter for this, because the chance of that happening is so small that and you're never going to have 100% probability in reality anyway. But but it sounds like it shouldn't ever, if you've got a probability of 0, that shouldn't ever say that they have been cured. So there's something going on. So maybe we'll just double check. It sounds like
I wrote exactly like that. So
if you post your code on Slack, and I'll have a look and see if I can see anything there. Let's move on. There's just a little bit extra I just want to talk to you about in terms of object-oriented programming just before we break for lunch. So, really useful feature in object-oriented programming is something known as inheritance. And I briefly mentioned inheritance when we talked about, in the principles of programming section, about object-oriented programming. I mentioned about the concept of inheritance. So sometimes we might want to have a class that's very similar to another class that we've already defined, but it's just got a few key differences. Okay, and rather than setting up a completely new class where we have to redefine everything again, what we can do using inheritance is to say this thing is like this thing in 90% of ways. It's just got these added extras and these added bells and whistles. So, for example, imagine we want to set up rather than having an ambulance as an instance of the vehicle class that we showed earlier, maybe we could have the vehicle class, but then also have a separate class called ambulance that's exactly the same as a vehicle class, except has the addition of maybe an attribute indicating whether the siren's going off, which obviously wouldn't be the case in most other vehicles. And we can use inheritance to do this. So let's take that example and think it through. So let's imagine we've got a class here called vehicle, and it's got a couple of attributes. It's got the number of wheels, which is an integer, and it's got a passenger capacity, which is also an integer, and it's got one method, which is to drive at a certain speed. And let's imagine we want to create an ambulance class that has all of that. It's just got a few little extras. So it's got, in addition to these attributes, it's also got a Boolean to indicate whether the siren's on or not. And it's got a couple of extra methods, one to turn on the siren and one to turn off the siren. But in all other ways, it's identical to a vehicle class. And what we can do is we can use inheritance so that when we create the ambulance class, we can say, use vehicle class as the template for this. I just want to add some extra bits to it. And if we do that using inheritance, then what we do is we refer to the vehicle class, the one that we're inheriting from, as the parent. So this is known as the parent class. And the new class that we're creating that's inheriting most of the stuff from this parent is known as the child. So basically the child will inherit all of the attributes and methods of the parent, but it might also have some additional ones itself as well. In fact, it should have something in addition, otherwise there'd be no point in creating a separate class. So you're creating a new class here called ambulance, but we're pulling in all of this stuff because rather than rewriting all of this stuff, and you might have loads of methods, for example, you might have 20 methods. You don't have to write all those out from scratch all over again if you're going to use them all again here. So what Python allows us to do is to say, I want, this is my parent, I'm inheriting everything from my parent, but there's also a few little extras as well. So let's look how you would do that in Python. And it's actually really, really easy to do that. So here we've got our vehicle class that I described. This is the parent that I defined with our constructor here. That's got number of wheels, passenger capacity, and I just put owner in here as well. And I've got a method here called drive, which takes in the speed and prints a message saying you're driving at whatever speed. So that's easy. And let's say we now want to create a class called ambulance that's going to be a child class that inherits from vehicle as the parent. And the way we do that, rather than having to write out all of this stuff again and then add in the bits we want, we can create our new class in the same way we would before. We give it our name, we use the class keyword, give it our name here, but we add some brackets. And inside those brackets, we give the name of the parent. So here, I'm going to give the name vehicle, and that's the name of the parent class. Now that tells Python, this class is going to be a child class that's going to inherit all of the attributes and all of the methods from this parent class, in this case, the class vehicle. So then, when we set up our constructor here, rather than writing all of this stuff saying, I need you to assign the number of wheels, the capacity, and the owner, rather than writing all that out again, I can use the super function. And what the super function does is it says, the super function basically allows you to refer to the parent. So here in the constructor, I've got the same constructor as I did before, same thing's being passed in, except I've also got this siren on attribute I'm passing in as well. And the first thing I'm going to do in the constructor here is use super to refer to the parent. And then I'm going to call the parent's constructor with the number of wheels, the capacity, and the owner, the three pieces of information the parent needs. So what that does is that rather than writing all this out, I can just say, yeah, when I create an ambulance, I want you to create, use all of the stuff from the constructor and the parent, and here's the pieces of information you need to do that. So call this. And then the only extra bit is I also want then this extra attribute called siren on that I'm going to set here. So this single line of code replaces all of this. Now, obviously, there's only 3 lines of code there. It's not wouldn't be too much of an effort for us to write that out again. But imagine your constructor was 100 lines of code. Suddenly, just having a single line of code which just says, just run the constructor for the parent, makes things a lot easier. So that allows us, because we've used inheritance, to refer to the parent using the super function here. And as with any other class, we can set up new methods in the normal way. So if I want to add in a couple of methods into this child class, I can create this. So I've said I wanted to turn on siren and turn off siren methods. These aren't going to take any inputs other than self. And all turn on siren will do is just switch this new attribute in the child class of siren on to true, and the reverse if we use the turn off siren, and it'll print a message in each case. But what we can also do, we can overwrite existing methods. So let's say in the ambulance class, we do want the drive method, but we don't want it to run in the same kind of way. And so all we need to do if we want it to run a little bit differently in this child class is we give it the same name, and it'll then overwrite this method from the parent with this method in the child. So now ambulance will have this version of drive that we specified here, which is exactly the same. In this case, it just says this ambulance is driving at. There's any difference there. But we can just overwrite that. So if we need one of the methods, we're inheriting the methods, but if we want to change it in any way, we can just overwrite it and define the new method here. And then if I run, if I instantiate a new ambulance, I can say my ambulance here is a copy of ambulance. It's got 4 wheels, got a capacity of 3. The owner is Dan, and the siren on defaults to false in this case. Then I can create my ambulance here, and then I can call the methods. I can turn on the siren and drive at 70 miles per hour. And I've been able to define this ambulance class much quicker than if I'd had to write out everything from the vehicle on top of all the new stuff as well. So it allows me to use this as a shortcut, basically. And you can have children of children. So if I then wanted to create a class that was a child of ambulance, I could do that. And I could create a new class, and I could pass in ambulance as the input to that. And it will then inherit everything from ambulance, which in turn will inherit everything from vehicle. So that new class will then inherit this new constructor, which also contains all the stuff from the old constructor, as well as the new methods I defined and the overwritten method of drive here. So I'm just going to shut the door to my cat's meow. Sorry, I don't think my cat likes inheritance. It's not an object-oriented kind of coding cat. Okay, so what we can also do with objects in Python, which is really useful, you've already had practice at sort of creating multiple objects, means we can loop through objects, and we can grab attributes from those objects, or we can call methods in those objects. So here I've got my vehicle class. I've got common name and number of wheels, capacity and owner, which I set up in my constructor, and I've got the drive method here, just as I had before. I've set up my 4 vehicles: Mike's ambulance, Sean's car, Alison's bicycle, and Tom's monster truck. And then I've added them all to a list here. So I've got a list of vehicles, and I've put those objects into the list. So you're used to seeing lists where you're putting in values, raw values like integers or strings or booleans or whatever it may be, or even lists of lists. So you can have lists within lists as well. But what you haven't seen so far is actually putting in objects. So you can also put objects in the list. So here I've got a list of objects. So my list contains these 4 created objects created from this class blueprint. And in the same way as with any iterable object, I can then iterate through this list, and I can do things with those particular objects. So I can then say for each vehicle in my list of vehicles, vehicle is now referring in each case. So go to the first one, Mike's ambulance. So Mike's ambulance is an object. So I can do whatever I would normally be able to do with an object. So I can check, for example, here I'm going to see if the common vehicle name, the common name for the vehicle is a bike. If it is, then I'll drive at a speed that's randomly between 2 and 12 miles per hour. Otherwise, if it's not a bike, I'll drive at a speed that's randomly between 20 and 70 miles per hour. And I can also print a little message taking in the capacity here, so the capacity attribute from that vehicle as well. So I can, here I'm going through a for loop, and I'm basically using the iterator here, vehicle, and whereas before this would, in lists, this would refer to a specific value, here it's referring to an object. So I can access the attributes and methods of that object as I iterate through a list. Another really key advantage of object-oriented programming, and one of the main reasons you want to use it, is because it makes things reusable. So that means that we can write some code, and then we can use it in other places, and even different programs entirely. So what we can do, we can store a .py file. So we can save a piece of Python code that represents what's known as a module. And a module is basically just a piece of Python code that has multiple different class definitions and or functions. And then we can import that elsewhere in the same way you're used to importing libraries in your code. We can do the same thing here. We can import a module library that we've written. And we can import either the whole thing, or we can just import certain methods, for example. So let's consider an example. So here I've written a file called pencordwizardry.py, and this is my module. And in this module, the first thing it does is import the random library, and then it has a class definition here, which defines what a pencordian is. And in this class definition, the constructor takes a name as an input. It sets up the name as an attribute, and it also has an attribute, a Boolean attribute here called is_a_wizard, and that defaults to false. And then it's got a couple of methods. So we've got a method here called writeModel, which takes as an input a type of model, and then it prints a message saying this person's name is now writing this kind of model, whatever's been passed in. And it's got a method called tellJoke, which takes in a probability of success. And basically this just takes a random sample from a uniform distribution in the same way you saw before, checks it against the probability of success, and then either the joke will work and people will love it, or it won't, and the joke will fall flat. So I've got a class definition here with some attributes and some methods. And then separate to that, also in my module, I've also got this standalone function, which isn't part of Pencordian, the Pencordian class, which is its own function here that I've written. And this is just a function which turns someone into a wizard. And basically the input subject must be an object that has a name string attribute and an is_a_wizard Boolean attribute, which obviously Pencordian, the Pencordian class, meets that criteria. But it may also be used for other objects. There might be another class that has, as long as it has those two things, then I can use this method, this function on it. So this method I've just called turn into a wizard, takes as input the subject, which is an object, and it sets their is_a_wizard attribute to true and prints their name is now a wizard. Okay, so that's one py file. I've just saved that as a separate .py file as its own sort of self-contained thing. And then let's imagine that I've now come back on a different day and I'm now writing a separate piece of code. And so this is a separate py file that I'm writing here. And in this py file, I'm going to import the random library, but I'm also going to import Pencord Wizardry, which is the name that I gave to this module. So by doing that, I'll import all of this into my code, which means that I can now use any of this, in that I can now create Pencordians because it'll know what a Pencordian is, and I can use this standalone method here as well, turn into a wizard. So I can import that all of that stuff just by using import Pencord Wizardry. And then I'm going to, in my separate code here, I've set up a list of Pencordian names, names here, and I'm going to randomly select 3 of those names. I'm going to use something called random.sample, so that's a function of the random library. Random.sample is quite a useful little function. Excuse me, it basically allows you to randomly pick a number of elements from a list without replacement. So if I pick one name and then I go to pick another, that name is now no longer choosable. So this allows me to randomly pick 3 items here. So I can give the list I want to sample from and also the number of samples I want to make. There is also a version where you can pick with replacement. In other words, if you pick the name Alison there, you can then, the next time you can pick it again, and then use random.choices, the random.choices function if you want to do that. Just a little aside there. So I'm going to randomly sample 3 of these names, and I'm going to store that in a list here, chosen Pencordian names. And I'm going to set up a blank list here called list of Pencordians. And then I'm going to iterate through my list of 3 randomly chosen names in chosen Pencordian names. And for each of those names, I'm going to add to my list of Pencordians a Pencordian. I'm going to create a Pencordian object. And I'm going to do that because I've already written what a Pencordian is as a class in my Pencord Wizardry file, which is completely separate. And I've imported that. So I can now use that as though I'd written it in this code. So I can refer to it and say Pencord Wizardry dot. So I want to use the Pencord Wizardry file, the module, and I'm going to use the dot notation to say it's something in Pencord Wizardry. And the thing I want is a Pencordian, which is a class definition. And that class definition needs as its input a name to set up a new Pencordian. So what this is doing is it's saying for each name that I've picked here, create a new Pencordian using the class definition I set up in the pen called wizardry.py file, and use the name that was randomly selected as the name to create that pencordion. So that will then create 3 pencordion objects with their separate names. And then I can, now I've got those objects, I can call the class methods from them. So I can say for pencordion in list of pencordions, I can iterate through my new list of pencordion objects, and I can tell them to write a model, and I'll say to write a discrete event simulation model. I can tell them to tell a joke with a 0.1 probability of success. So you can see here, if I run that, in this sample, Martin was then writing a discrete event model. He attempted a joke, it fell flat. Dan's writing a discrete event model. I attempted a joke and people loved it, of course. And then Sean is writing a discrete event model. He attempted a joke and unfortunately that fell flat there as well. I won't tell you how many times I had to iterate through to get to that combination where people loved my joke and my joke only. But you can probably guess given the low probability there. But the key point here is that I've written a piece of code here that I've saved as its own .py file, and I can use the stuff there in a completely different piece of code. And that's really useful. In this previous example, we imported the whole of pen called wizardry, but if you've written a really big module, then you may not want to do that. And in fact, you'll see as we go on in the course that when we import other libraries that you haven't written, sort of big libraries that are used, we don't tend to import everything because it's very inefficient because they're huge. And we may only need like one of the functions that have been written in that module. So if we only need something specific or a couple of things, we can just import those things rather than import the entire module. So here, let's just say actually the only thing I need from my pen called wizardry module is this function. I'm not interested in this class definition. I just need to use this function over here. And so I can do that. I can say from pen called wizardry, import turn into a wizard, which was the name of this standalone function I had down here. So I can just import that. So it's not imported the entire file. It's just imported that function definition. And because I've imported that, I can now use that function as though I'd written it in this piece of code. So here I'm going to create a new class I've called HSMA, and that's got 2 attributes, a name, which I pass in, and is a wizard, which is defaults to false. So remember, we said when we wrote this method that the 2 requirements are whatever it needs a subject that's passed into it, it needs to be an object, and it has to have 2 attributes, a name and a boolean that says whether they're a wizard or not. So I can use that here for my HSMA class. I can create a new HSMA object, which I've called my promising HSMA, and I've given them the name Gandalf, and that obviously creates an instance of this class. And then I can turn Gandalf into a wizard using the function that I imported from the pen called wizardry module here. So I can do that just by calling that function. I haven't even written it. This is a completely separate file. I haven't written that function here, but I did write it in that other file called pen called wizardry, and I've imported it. So it's as though I wrote it here. And I can call that on this newly created object here. So here I've used that function that was written for a completely different purpose, and I've used it for a different class that I've written over here. So it's a really useful way in which we can reuse code. Okay, it's lunchtime now. Any questions before we break for lunch? Okay, you're probably exhausted. So that was object-oriented programming. It's a bit of a whistle-stop tour, and as I say, you'll get lots of practice using object-oriented programming throughout this course and throughout your projects, and you'll get lots and lots of practice doing this. But hopefully it'll now make more sense when you're importing things about what's actually happening and what you're actually doing. Okay, so let's break now till 1:30. You can stay on the call, so letting you back in. So feel free just to keep yourself muted and remain on the call. We'll resume at 1:30. So this afternoon we're going to do 2 things. We're going to be talking about a fantastic library called Matplotlib, where I show you how to generate some really nice graphs using data in Python. And then you're going to have some practice at the thing you'll be doing most of all in any coding and that's working out why your code doesn't work. And so you get a bit of a practice on doing that using a rather devious challenge that I've concocted. But for now, go and stretch your legs, go and have something to eat, and forget all about Python for the next 55 minutes. And I will see you at 1:30. So see you in a bit. Okay, hi everyone. Welcome back. Hopefully you managed to get a bit of break over lunch, had something to eat, and forgot all about object-oriented programming for a little bit. So this afternoon we're going to cover the two final things in the kind of introductory Python sessions. As I say, this is by no means the two remaining things left to learn in Python. Because there's a huge amount, and as I said to you right at the start, there's no way that I can teach you everything you need to know in Python. Really, this is here to teach you the basics, and then you'll get lots more practice, and you'll see some new stuff as we show you the various methods over the coming weeks as well. But hopefully, these sessions will give you a bit of a sort of basic grounding in fundamentals of Python programming. So the two things we're going to do this afternoon, the first is plotting graphs using Matplotlib, which is going to be particularly useful for the sort of things that you are all going to be doing, and it's a really nice package. And the other thing is debugging, so learning how to try and efficiently work out what on earth is going wrong with your code and giving you a bit of practice on that. So let's start with plotting. We're going to be using a package called Matplotlib. So if we're going to be building models or data science algorithms in particular, or analyzing data in any way, we're likely going to be wanting to visualize that information in some way, i.e. we're going to probably want to plot graphs. Now, we could export the data from, let's say we've built a discrete event simulation model, we could output that as a CSV and then put it into something like Excel and plot it there. But actually there's very nice built-in stuff in Python that allows us to do this natively and with much nicer sort of results than you would get using something like Excel, for example. Now there's also plotting packages out there. One of the most widely used is something called Matplotlib. Now, probably one of the key drawbacks of Matplotlib is that because it's so popular, traditionally it's had a huge number of different ways of doing exactly the same thing, including both object-oriented and non-object-oriented approaches. Therefore, the things I'm going to show you this afternoon, you may see lots of code out there that does the same thing but in a completely different way, or indeed for anybody that's used this before, you may be used to using it in a different way. Now, Matplotlib's developers are, in light of the fact that there are so many different ways of doing stuff, they're now recommending exclusive use of the object-oriented way of doing things. So the way I'm going to show you this afternoon is kind of the official Matplotlib recommended approach. That's not to say by any means, as I say, that this is the only way to do it. In fact, if you are used to using another method and you prefer that, that's absolutely fine. But just be aware that this is the way they're trying to push people into using a more standard sort of approach now. So this is what we're going to teach you. So if this is less of a problem if you're new to Matplotlib because or you've already been using this approach, because this will be you won't be familiar with the other things anyway. But it's something just to be aware of, particularly as you're going to see lots of code out there, and you may be wondering why on earth this way of plotting a bar graph, for example, looks completely different to the way that Dan taught us, and that's why. Okay, so the first thing we need to do, as with any package that we're going to use, we need to make our necessary imports. So here we're going to make the import. Now this import statement is probably the most commonly used import statement that you'll be using when you're using Matplotlib, and that's we import matplotlib.pyplot as PLT. So this .pyplot basically gives us a MATLAB style plotting interface that's the most commonly used, and we use the common alias PLT, much as we did with NumPy and Pandas, NumPy being NP, Pandas PD. We use PLT for matplotlib.pyplot. So we're not importing all of Matplotlib. Remember I said this morning, we don't typically want to do that with very, very large packages. We're just importing the pyplot stuff, which is what we want to use here. So because we're going to be showing you the object-oriented approach, we need to think about what the objects are in the Matplotlib library. And there's basically two objects in a Matplotlib graph. And these can the names of these can seem a bit odd if you're not used to using this. So it's worth just getting this into your head early. Some of the nomenclature they use. So they talk about a figure. There's a figure object. The figure holds the graph, so it's like the plotting area for whatever you want to plot. Within that figure, so think about if you were writing a research paper, for example, you might have various figures in your research paper or in your report. Those figures, though, may be made up of multiple subplots. You may have a figure that holds multiple graphs within that figure. And those subplots are referred to as axes. So an axes object in Matplotlib represents a subplot within a figure. So the figure is kind of your overall plotting area, which will contain one or more graphs, and an axes object is a subplot within that figure. A lot of the time, you're only going to have one axes object in a figure. So in other words, you'll just have one plot per figure. You may, of course, have multiple plots or lines. So if you have a line graph, you might have sort of multiple lines on your graph. That's different. I'll show you how to do that. But in most cases, you'll probably only have one axes object. But you can have more. So, for example, you might have multiple subplots where you've got a couple of graphs side by side, or you might have four in one in each corner in that same figure. And if you do that, you need multiple axes objects. Now, I'm not going to cover that this afternoon. I'll briefly mention the bit at which you put that in. But I am going to show you, you've been given access to the official Matplotlib cheat sheet, which is a particularly useful document. And that will show you how to do that as well, if that's what you want to do. Okay, so let's just start simple. Let's just imagine that we want to plot a really basic line plot. Okay, so the first thing I'm going to do is import a matplotlib.pyplot as PLT. That will give me my MATLAB style plotting interface in Matplotlib. And then I'm just going to set up some dummy data to plot. So here I've got two lists of numbers. One list represents the values that will be plotted along the x-axis, and one the values along the y-axis. And we're basically just going to create a plot that plots those two values against each other. So the way we're going to do that, the first thing we need to do is to create our figure and axes object. As I said, we're only going to be looking at single axes in a single figure in these examples. So the way we do that is in this way here. So we store the name, this figure ones is our figure object. Obviously, we can call that whatever we like. That will store this particular figure, which will contain one or more subplots. And the ax is the common name that you tend to use, although again, you can use anything to represent, if you've only got a single axis, a single subplot in your figure, then that's the name you tend to use. And we use PLT, which remember is shorthand now for matplotlib.pyplot. So that's too fast. And we use the subplots method. And what that will do is, if we do that and we don't pass anything in, it'll just return a figure and an axes object. Now, here's the bit where if you wanted more than one subplot, you can put this in brackets. So in the subplots bit, in the brackets, if you wanted to say a 3x3 plot, so you got 3x3 graphs in your single figure, then you could put 3, 3, and that will give you a figure, a single figure with 9 different axes objects. and then you would tend to change the AX name here to AXS, and that would return essentially a list of axes objects. Don't worry about that when you're starting out. As I say, most of the time you're only going to be using one anyway, but there is information in the cheat sheets about how you can do that. But that's basically where you would do it. But for now, we're just going to have a single figure and a single axis, single subplot. So we create the objects here. Then what we do is we call the plot method on the axes objects. That's the subplot, remember. And the dot plot method will basically give us a line plot, gives us a simple line plot. And all we need to pass into that are the two pieces of data that we want to plot against each other. So in this case, it's is X and Y, the two lists of numbers that I've set up here. So this creates the objects. This calls the plot method on the ax subplot. And then all we need to do is show the figure. So we call that on the figure object. So we say figure 1 or whatever we called our figure dot show, and that will then show what we've plotted. And obviously, if there were multiple subplots, so multiple axes objects, it would show them all, or everyone you've defined. But obviously, we've only got one here, so we'll just show that. And you can see here that will then generate this plot here, where we've plotted this data against this data. And we can see we've got in the x-axis, we've got we're plotting the numbers 1 to 10. And then for the value 1, we're plotting a value of 3. For the value 2, we're plotting a y value of 7, etc., etc. So really simple plot. And a common line plot is probably going to be something you'll commonly use in a lot of your stuff. Now, we probably don't just want a very basic graph with no text on it. We probably want to at least, at the very least, label our graph axes, not to be confused with Matplotlib axes, which are subplots. So we want to name our x and y axis in some way and label them. And we can do that really easily. So once we've created, this is all exactly the same code with just one addition. So once we've created our figure and axes objects, at that point, after that, and before we plot it, we can set the labels for the x and y axis. And we do that using the methods of the axes object. So remember our axes, our subplot is called AX. And so here I just say ax.set x label, and then give whatever I want to call my x axis, and then the same for the y label here for the y axis. So I've called mine time against number of patients. We might also want to, of course, change the color or style of the line. And again, we would do that after we set up the objects. But in this case, we do that at the same time we plot. So whereas before, if we look here, when we called the plot method of the axes object, we just provided the x and y data that we wanted to plot. Here we're going to pass in a couple of extra arguments to basically tell Python how we want that line to look. So the minimum is we need an x and y to plot, but we can also put in these optional extras as well. Now, I think it's probably the first time you've seen this, where you can put the name of the, so up until now, when you've passed inputs into a method, you have put them in the exact order in which it's expecting them. But you can also use these keywords here to say the thing that you're expecting called color. Note the American spelling here, you need to be mindful of that, so don't let that trip you up. Equals, and then whatever value you want to give it. So I could swap those two around and say line style first and then color, and it wouldn't matter because if you put the name and then equals and then the value, then it interprets it in the correct way and fills in the correct attributes for those. So here I've set my line color to red, and I've set my line style to a dashed line there, and we use the two hyphens within a string there to note that. Again, on the cheat sheet, it'll show you all the different combinations of lines that you can have, line styles and colors, and there's huge amounts of different styles you can have. So I'm just using a simple combination here. So a red dashed line, and then again, I show my figure, and we've now got the same plot, but with a red dashed line. Now, as I mentioned before, it's likely you're probably going to want to, particularly some of the stuff you're doing, add multiple plots within the same graph, within the same subplot. And that's probably going to be a common thing that you're wanting to do. So let's imagine, for example, we had some sort of ED data, and we were plotting the number of patients in the ED against the number of doctors that were in the ED over time. And so we might have time as our x-axis, and then we got two plots that we want to plot. We want to plot the number of patients over time and the number of doctors over time. And we can do that really easily in Matplotlib. So I've got my data all set up here with my time, patients and doctors as 3 separate lists. I'm going to create my figure and axes objects in the same way as before. I've set my X and Y labels in the same way as before. This time I've got time against number in clinic. And then when we come to plot them, all we need to do if we want to plot another line is just call the plot method a second time. So in the first plot, I'm going to call the plot method of the axes object. And here I'm plotting time against on the x-axis against patients on the y-axis. I'm going to color that blue, and I'm going to have a line style single dash. So that just basically means a solid line, which is the default, by the way. And if I then call the plot method again before I show the figure, then it will plot another line on the same graph. So I just do exactly the same again, but this time I'm plotting time against doctors. And they'll be colored, that line will be colored red, and it'll have this dotted line here, which we use the colon to notate. And then if I show the figure, you can see it's created this graph here with 2 plots on the same graph. The blue line representing our patients over time, and the red line are doctors over time. So really easy if you want to add in an extra plot. Of course, if you wanted to add a third plot, you just put another ax.plot call there and tell it what you want to plot and how you want it to look. Now, of course, if you've got multiple plots on the same graph, you're probably going to want to add some sort of legend so that people know what those different plots represent. Otherwise, they'd have to guess. So we can do that really easily. All we need to do when we call the plot method to create a line plot on the axes object, as well as specifying the data we're going to be plotting and the style in terms of the color and the line style, we can also add an extra argument which gives the label. So on the first one, the label will be patients, and on the second one, the label will be doctors. And that labels it, and then all we need to do is tell it that we also want a legend, and it'll automatically pull in those labels automatically that we've given for those plots. And to do that, we just use the legend method of the axes object. So we just say ax.legend, and we can tell it here where we want it to locate it. So loc means locate, and we say loc. I'm put mine in the upper left here. And again, the different combinations of where you can put it and what you need to write in here are all on the cheat sheet, so you can refer to that. It's a really handy little document. So we just use that to specify that we want a legend. So I've done, now note, I've done that after I've plotted the data, but before I show it. Okay, and that's important because you want it to plot so that we can specify what the labels are. The axes, sorry, the legend needs to know what the labels are for each line before it can generate the legend. So here you're creating the figure and the axes objects, giving the X and Y axis labels, and then plotting on the line plot for your 2 different plots, giving them labels, then setting up a legend, and then showing it. Ignore this bottom bit for a moment. I'll come back to that in a second. Now, of course, it's not just line plots. As you can imagine, there are huge numbers of different plots that you can do in Matplotlib. I'm just going to take you through a few of the very basic ones, but again, the cheat sheet will show you all the different fancy combinations that you can do, anything you can imagine pretty much. So let's start with a nice simple one. Let's think about bar charts. So let's imagine we wanted to plot the HSMA trainers against the number of hours of teaching that each one is delivering. I promise you I haven't done this just to rub it in how much more I've got than everybody else. So here I've got my data as I had before with my HSMA trainers, just a list of strings and then a list of numbers for the hours of teaching. I set up my figure and axes objects in exactly the same way as before using the plt.subplots. I set my X and Y label in exactly the same way as before. So my X label I'm going to have saying trainer, my Y label, hours of teaching on HSMA. And then the only difference is that instead of saying ax.plot, which will generate a line plot, I use ax.bar, which will generate a bar chart. And the two things I'm going to pass in to that method are the two pieces of data, the X and Y data. So the X data being the HSMA trainers up here, and the Y data, the hours of training. So for each HSMA trainer, what's their equivalent hours of training? And plot that on a bar graph. And then we show it. So exactly the same as before, just with a different call when we come to actually plot it. We can do scatter plots as well. So again, got my data up here that I've called A and B, two lists of numbers. I'll plot these against each other. And I set up my figure and axes objects exactly as I did before. I set my X and Y labels exactly as I did before. Just put my variable A and variable B. And then this time, instead of ax.plot or ax.bar, I say ax.scatter. And I provide to that the X and Y data that I want to plot against each other. So in this case, A and B. And then I show it. Exactly the same as before. So it all uses a very standard structure. And basically what you're doing each time, you've got your data. Obviously, in reality, that will either be generated by your model, or maybe you're reading something in from a file. And then you create your figure and axes objects. You label your X and Y axis, and you set up any visual options you want. And then you plot it with any particular options. You put in a legend if you want a legend, and then you show it. And that's basically the standard way of doing it. So I mentioned we've given you a cheat sheet. This is the Matplotlib official cheat sheet. You can access it online, but we've also given it to you in your lecture materials from today. So do use that. It's really, really handy to check out and to instantly look up the different types of plots you can do. You can do all sorts of contour maps and all sorts of things, box plots, some great stuff. And it'll show you how to do the subplots and stuff as well. It'll also show you how to do different colors and the different color codes that you need and where to place your legends and all sorts of fancy stuff. So it's a really useful little reference material. And also I'll just give a plug to my colleague Tom, who's got some fantastic Matplotlib tutorials, which will go into a bit more depth than we're going into for this particular session. And there's a couple of links there. So I'd encourage you to check those out. Really easy to read, doesn't assume that you've seen Matplotlib before, and it'll guide you through creating some graphs and all the options you can do for that. Now, obviously, if we've created some graphs, we probably want to save them for future consumption and enjoyment. It's really easy to save figures, and we've got a couple of options. If you're using Spider, then you'll have already seen from one of the earlier exercises we did a couple of weeks ago that it stores them in the Plots tab in the top right window. And you can click on that, and if you want, you can just right-click any of those figures and click copy and paste them wherever you like. So that's an easy way to just grab out a particular graph, or we can save them directly from our code, and we can just use this very simple command to do that. So we use the save fig method of the figure object. So remember, my figure is called figure1, and I just say save fig, and then I just give the file name of what I want to call it. And so I'm going to save that as a PDF. That will then save that figure as a PDF. If you wanted to put in to store it in a particular folder, you can put that in the file path as well. Okay, any questions about any of that? Right, okay. Matplotlib isn't too difficult to use. It's probably a little bit easier than what you were doing this morning, actually. A bit of a light relief. And it's very easy to get graphs, really nice looking graphs, actually, quite easily from your data. It's a really nice habit to get into, to use something like Matplotlib for plotting the data that comes out of your models or your machine learning algorithms. Okay, so let's have a practice now to practice what you've learned. So what I want you to do is I want you to work in your groups. I want you to write some code that plots a line plot comparison of hospital A and B using this data here in terms of the mean number of ED attendances per day of week. I want you to use different colors or styles and a legend, so you can clearly differentiate the two lines on the plot and label each axis appropriately. You should also force start the y-axis from 0, because these are very high numbers, and it won't automatically do that. If you don't do this, it will automatically start the x and y axes as numbers that are not at 0. So it's very important that you do this. Now, I haven't shown you how to do it, so I'm just going to test you a little bit by explaining it here, and hopefully giving you object-oriented programming teaching this morning. This should make sense. So the way you do it, we want to force start the y-axis from 0, and we're going to use the set ylim method, and that's a method of the axes object, and you'll pass into that ymin equals 0 as the parameter value, and that will then tell it to force the y value on your y-axis to start from a y value of 0. Now, very importantly, you have to do this after you plot the data, but before you show the figure. If you don't do that, if you plot it before you plot the data, if you do this before you plot the data, it won't rescale properly. So you have to plot the data and then tell it that you want the y-axis starting at 0, and then show the figure. Otherwise, as I say, it won't work. Once you've done that, I also then want you to set up a new figure that plots on a bar chart the total mean ED attendances across both hospitals by day or week. So total for Monday for hospital A plus B, total for Tuesday for A plus B, etc. And use various formatting. So I've provisionally given you sort of 30 minutes for this. You probably won't need that, but we'll see how you get on. If you do finish early, I'd encourage you to check out some of the other Matplotlib stuff. So have a look at the cheat sheets and see what other kind of fancy graphs you can do and have a practice using some of that stuff. So basically have a play around for the next 30 minutes on Matplotlib in your groups and see what you can come up with. Okay, I will stop sharing and I'll open up the groups. Hi everyone, okay, welcome back. I think you all did really well bouncing around. It looked like you all got the hang of this quite nicely. It certainly was a lot easier, I think, than the stuff I set you this morning. But I'll go through the solution for completeness. Okay, so first thing we want to do is import matplotlib.pyplot because PLT. And then I've just set up my data here. Now, as in reality, you won't be typing in the data by hand. This is just for the purposes of the exercise. It'll likely be generated from your model, or you'll be reading in from a file or something like that. But yes, I've got my day of week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday here. Actually, whilst I think of it, now this is something that I was prompted by seeing a few of your screens. So something I've noticed a lot of you are doing is going over the line very slightly. Now, I did say about not going over the line. What I didn't do is explain how you don't go over the line, except for strings. So let me just explain, because this actually shows it here. Basically, you can separate any line of Python code into multiple lines as long as it's in brackets, just by hitting enter. So this line here. Oh, I think it's common. Okay, let me do it before I start ruining that. Let's do it over here. So let me show you an example. So a lot of you were doing, in this particular example, doesn't matter. Apparently I can't type. And obviously you were getting up to around here, and then suddenly you started drifting over the line. Now I heard a few, well, it's only a little bit over. I'm afraid it's still over. But fortunately, there's a really easy way to do it. So in the newer versions of Python, so used to, in the old days, you had to use the backslash in order to separate onto multiple lines. You can still do that. And Python is fine with that. The better method now is just put things in brackets. Now, very often when you're going over the line, you're already in brackets because it's some sort of long list or something like that. So you can just hit enter and it will automatically, you'll see Spider will have the correct indentation showing you this is all part of the same line. So this will be read as a single line. Now, the advantage is that as long as, and you can use it with any type of brackets, square brackets, curly brackets, normal brackets, the advantage is you can put anything into brackets in Python, even if it doesn't need to be. So imagine we're just, we've got something like this, where you're just adding up some, it's a pretty bad way of adding up numbers, but it's just speed, etc. So you don't need brackets for any of that. That's a perfectly fine statement. However, you can put that into brackets. There's nothing stopping you doing that. So if you put that in brackets, you can now hit enter after any of your plus commands there, and it'll automatically separate that out into multiple lines, and it'll be read as the same line. So just be aware that's a really easy way to do it. So as long as you're in brackets of any kind, you can separate things out. Now, obviously, what you can't do is in the middle of a variable name, just sort of hit enter, where you can, but it'll misinterpret it. And remember, for strings, so you're using F strings, we just separate them out with commas in our brackets anyway. So you've been used to seeing that, but not so much the other stuff. Anyway, I just wanted to flag that up because it's a useful little tip to know, and it's much easier to separate it into multiple lines now. Okay, so back to this. So I've set up my day of week list, my hospital A and B ED attendances lists. Then I set up my figure and axes objects using the plt.subplots. Then I set my X label, I've just called mine day of week, and my Y label, I put mean number of ED attendances. And then I plot my two pieces of data that I'm going to plot on the same graph. So my first plot is going to be day of week against hospital A's attendances. I'm going to colour that green. I'm going to have the solid line style. Now remember, it will default to that. You don't have to specify that, but if you're specifying line styles elsewhere, it's good practice to specify what line style it is, so that people can see that at a glance, and also that it makes it neater and easier to change if you want to change it to something else. And I've set my label to hospital A, and then for hospital B, I've done another plot. This one's going to be dark violet with the hyphen dot line, which we'll see in a moment, and my label is hospital B. Now, because I've set up my labels here, I can then create a legend using ax.legend. I'm going to put mine in the lower right. Then here, this is a point at which I would need to do my thing where I tell the y-axis that I want it to start from 0. Because these are large numbers, it won't default to doing that. It'll automatically rescale. I think it was around 150 if you don't do it. So you may want that, but you need to be careful when you're doing plots like that people don't misinterpret. So you need to be very clear if you're doing a plot which doesn't start from 0. That's what it's doing, because people won't necessarily notice. But in this case, if you do want to change it to start from 0, then this is the point after we've plotted, but before we show, and that's the correct point to do it. If you do it anywhere else, it won't work. Then I'm going to show my figure. And then for the second bit, I've got total mean ED attendances. Now, there are multiple ways in which you can do this. This is actually the least efficient way I've got here, but is the sort of simplest, spell it out method. I saw some people were using list comprehension, which is superb. Absolutely, I would advise that. People using NumPy arrays, again, fantastic idea. And in reality, you wouldn't plot the data of, it's highly unlikely you'd plot the total mean across two hospitals. That's unlikely. But if you did need to add together two sets of data, then NumPy is probably the way to do it. And you're probably going to have your data in a pandas data frame or NumPy array anyway. And then if you remember back to last week, we talked about how NumPy was really nice for being able to do really simple array calculations. So if you want to add the numbers in two arrays together, you just say array A plus array B, and it'll add them together for you much more efficiently than this, which is the sort of old-fashioned way of doing it, where I'm just going to go basically through. I've set up a new list that stores the totals, and then I'll go through each iterator for the length of hospital A attendances, and I will add to that list hospital A plus hospital B for that particular entry. But that is the least efficient way of doing it. But obviously for this, it doesn't matter. Then I'm going to set up a new figure and subplot. Remember, these need to be separate. So I had to call them something else. So I've called my figure 2 and axis 2. Set up my X and Y label axis labels as I did before. And then this time I'm going to plot a bar chart. So it's going to be day of week against total mean ED attendances, and then show that. And then if I run that and go to my plots tab, about that. There's my bar chart. Over there, and there's my very nice looking line plot for the first bit. Any questions about any of that?
Dan, just we got this message that you're also getting, I see, about the show thing. Do we need to know anything about that? Don't worry about it. It does. That's a common. It's a warning rather than an error, it's because so basically in Spider your plots are dealt with separately here. So it's basically just telling you it's not going to plot in the console itself, because that's not the IPython console is not a graphical user interface backend. That's all it's saying. Okay. Well, hopefully that was a bit of a sort of whistle-stop intro to Matplotlib, but hopefully you can see it's actually really easy to generate some really nice plots in Matplotlib, and it's a really nice way of presenting your data. So when you're going through and building your models and your machine learning algorithms, I'd encourage you to use Matplotlib to plot the data that's coming out the other side. Because I think it's a really nice way to do that, and really easy to do. Okay, let's move on to the next bit. In fact, the last bit of the introductory Python training, debugging. So far, hopefully, what I've shown you has been, over the last few weeks, has been fun, and you've enjoyed it. And some of it's probably a bit more challenging than other bits, but hopefully it's been sort of interesting and fun to do. I can't pretend this bit's going to be very fun, but it is unfortunately very necessary. So if you're new to coding, you will swiftly find, particularly as you start out, but it won't really get much better, that you'll actually spend a decreasing amount of time actually writing code and an increasing amount of time staring at your code, shaking your head and wondering why on earth it isn't working. And unfortunately, that's just par for the course of being a coder. That you will have to debug, things will go wrong, and you will have to try and find what's going wrong in your code. And trying to find the errors and fix those problems in your code is a process known as debugging, to remove the bugs. Or if you get very tired of it, keep it in and call it a feature. The Python interpreter will actually help you if something goes wrong, and you'll have already seen this lots of times because you've all been sort of running code in your exercises, and you'll occasionally get an error message pop up, and you'll probably have found that sometimes that error message is really helpful, and then there are other times when you look at it and feel like you know less than if it hadn't told you that. So it's a useful first start, but there are cases where you get, particularly when you start getting into using things like the TensorFlow, which we'll be using for the machine learning, and starting to get into the really advanced software, you'll get some very odd error messages that appear to have no relation to what the error actually is. They do. It's just there's a very odd sort of trace back, and there's a number of logical steps you have to make in your head. Now, I'm not going to go into any of that this afternoon, so that would be cruel. But I am going to give you a bit of practice in the upcoming exercise to try and get used to fixing things, and not just fixing things, but testing as well, and going through and thoroughly testing your software. Remember back in the first session we talked about validation and verification. Very important to not only make sure that your model or whatever you're building is a good enough approximation of the real world system to answer your question, but also that your code is actually working the way you should. And that doesn't just stop at the code actually running, because code can run and it can be a load of nonsense. So getting into thorough testing and making sure everything is working as it should is actually very important. So as I say, the Python interpreter will help you, but it's not foolproof, and sometimes it can be a little bit unclear about where the error actually is. And I've got a little example of this coming up. Before you get onto the exercise, though, I'm going to just go through a few examples. I'll start them off fairly easy, and I'll just ask people to shout out where you think what you think the problem is in each case. Do be aware that you're, particularly after a poll, I won't hear the first sort of half a second to 1 second of your audio. So perhaps as you say it, if you can say, I think the problem is, and then that will give me a chance for my speakers to kick in. Okay, so here's the first one. Let's start off with an easy one. What's happened here? If you can't read the bottom message, that it says type error, can't multiply sequence by non-int of type str.
You haven't cast integer?
I forgot to mute myself. Yes, that's right. I haven't cast it as an integer, so I've read in an input, and I've read that in as a string, but I haven't done anything with it. So now number is a string value, and therefore number multiplied by number can't work. So that's a fairly easy one, and that error message, as long as you're sort of aware of string, casting integers, shouldn't be too difficult. Okay, let's have a look what's happened with this one, which says index error, list index out of range.
I think it only goes up to 2.
It's a common one, particularly when you start out coding in Python, that you'll forget that if you want to access strawberries here, you actually need to put that as index element number 2, because it starts at 0. You get used to it after a while. So yeah, list index out of range is a very common one you'll see, probably not so much through this, but particularly where you'll usually find it where you think you've added something to a list in your code, and probably in a for loop or something like that, and that hasn't worked, and you won't notice that until you then go to access it, which may be in a totally different path, and then be wondering why you've got a list index out of range. It's probably that. Right. So this is one I nicked from another website. Then tell me what's happening here, which gave the error, name wait time int is not defined.
In the 4th row, we're referencing it.
It's the 4th line here. So we've asked for 2 inputs. That's all fine. We've then cast the first input as an integer and stored that as current time int. That's fine, that's good. But here we've done a little typo, and we've actually, we should have written here wait time str, which is the input here, and cast that as an integer. But this is a very common typo because they're very similarly named. You will do things like this, which is why it's very good to have very clear differences in your variable names. So what you've actually told Python to do is that to create a variable called wait time int, and the variable wait time int you've just created should be an integer casting of the variable you've just created, which obviously is complete nonsense. And that's why it says, hang on, I don't know what wait time int is. You've just told me wait time int is the integer version of itself. That's not very helpful. So that's basically what it's telling you. Okay, what's happened here? This one says syntax error, invalid syntax.
It means another equal, is A equal B.
Very common one, particularly when you start out in Python as well, that you'll, because it's natural, we in our heads say if A equals B. I hear, there are other people that have some things they do in the head. The way I do it, I always think of equals as strictly equals, and that helps me having that extra word in there to bounce in my head across the equal sign twice, but it is a common mistake that you'll make. So yeah, it should be if A equals B, because equals is the assignment operator, not equivalence. Okay, what's happened here? This one says syntax error, invalid syntax.
So missing a bracket in the and.
So we got some brackets missing. I suspect I could just feel all of you thinking, I bet it's the brackets, but you're trying to work out if it is indeed the brackets by trying to count this mess of brackets. Another good reason to try and avoid overuse of brackets in single lines of code. But yes, we're missing a couple of brackets there. So it's actually reading that in a very different way to the way you think it should be. Okay, what's happened here? This one says syntax error, unexpected EOF while parsing.
Is it because you haven't sort of told it what to do at the end of else? So it doesn't read, it's looking for the end of the file, essentially, or the end of the command.
So this one can trip you up the first time you see it, which is why I wanted to flag it up. Yeah, unexpected EOF means unexpected end of file. In other words, it reached the end of the file and it didn't expect to do so. And that's because the way Python's read this in, it's read all your variable assignments up here, that's all fine. Then it's read this if statement, that's okay, we've put in the correct number of brackets now. Print, yes, yeah, great. Else, right, and then you've put in a comment that says do nothing, but that's not code. Python ignores this. So the way Python has read this is if this, then do this, otherwise, and then nothing. Now, Python won't accept that. You have to put something here or don't put else. You can use the keyword pass, which just basically means do nothing, just carry on. So that is pass is the keyword you use if you want to do nothing. That can be quite handy if you're writing an if-else statement and, for example, you want to come back to your else logic, but you want to test the if bit. So you can just say else pass so that the code will still run. But yeah, basically what it's doing, it said, well, I got to the end of the file, but I was still waiting for you to tell me what to do if this didn't work, or if this wasn't true. So yeah, be mindful of that. Whenever you set up, and it's not just if else statements, anywhere that you set up an indentation, like a new block of code, such as if you define a class or a function or an if-else statement or whatever it may be, where you've got that colon and then that block of code, if you don't put a block of code or you just have comments and there's no actual code there whatsoever, then you will get that error and that will come up. So just be mindful of that. You can also get that error come up where you've got issues with brackets or with line breaks, where it thinks that it's still reading something because something hasn't closed, and therefore it gets to the end you think it should have closed, and it hasn't. So that's the other way in which that often comes up as well. Okay, what's happened here? Now this one's a bit trickier. There is a clue, but this is an example of where the clue isn't obvious. So here we've got a type error. It says start teaching is missing one required positional argument subject.
Has it not been instantiated?
Fantastic, yes, exactly that. So what's happened here, so you have to unpick this, because the first time if you did that and you're new to object-oriented programming and you got that error, you'd probably look at it and say, no, it's not missing at all. I've told you the subject, it's programming. What are you talking about? But actually the clue is there, it's just getting confused. So if we look at what's happened here, we've got our class definition, we've got our class called Pencordium, we've got our constructor set up here, that's all great, and we've got our start teaching method here, that's all great. And then what we should have done is create an instance of this class and given that a name, and that would then become an object, a copy of that class, an instance of that class. But instead what we've done here is called the class directly. So we've referred to the Pencordium. So this is now looking at the class, the blueprint itself, and we've called the start teaching method. Now you can do that, and you will see
I think, no, it won't be next week. It'll be in the more advanced session that we do on SymPy a little later in the course, when we come to do the object-oriented version of SymPy, that there are circumstances where you do have classes that you refer to directly, and you don't create instances of those. It's rare, but there are special cases, and you'll see why. So you can do it. There's nothing stopping you doing that. The problem is, because you're now calling the class directly, well, it's expecting two arguments here. It's expecting self as well as subject. So that's why you're getting this error. It's saying it's missing one required positional argument because it's taken the one you've passed in as programming as being this, self. So it's now waiting for this one. And that's why you get that error. So again, it makes sense once you know, but it can be a little extra jump to sort of trace that back. So that's what you're doing there. So in this situation, obviously you're likely wanting to be actually creating an instance of that class and not calling the class directly. But yeah, you'll get a few errors like, well, you get a lot worse than that, where you actually have to. It's not entirely obvious. It's telling you technically what the problem is. This is the reason that it fell over. That is strictly true, but it's up to you to try and then unpick that a little bit. Okay, right. Let's put this to the test in my favorite exercise for me, not for you, Dan's devious debugging challenge. So what I've done, I've given you a .py file called debugging challenge, and you're going to find a Python program that has a lot of errors in it. And your challenge, I want you to work as a team to fix the code and get it all working. Now, be warned, there are quite a lot of errors, and depending on how you count them, there are at least just over 50 of them. And some of them will be harder to spot than others. Now, what I'd advise you do is you try to work out first how the code is supposed to be working. And to make things harder, I've deliberately omitted all comments. So there are no comments in this code. So I've made your life as much hell as possible for this particular exercise. So, and it's to get you used to looking at code, trying to understand what's working, what it's supposed to be doing, and where things are going wrong. So do that first, and try and work out how it's supposed to work, because that will help you. Not least because you may be able to get the code running, but even if once it's running, it may not actually work as you think it should. So you don't just need to get it running, you need to thoroughly test it to make sure everything works as you think it should be. So I want you to work in your groups, and I'm going to give you an hour and see how you get on with it, and see if you can fix this horrible code. So have fun. I will be bouncing around enjoying watching you do this. People hated this from last year. I will just say, if it makes you feel any better that I'm putting you through this, I had to go through it myself, because when I first did this, first wrote the exercise, I completely forgot to note where the errors were. And so I had to go back through, sorry, I forgot to note where the errors were, and then I accidentally removed or deleted and overwrote one of the files, which meant I had to go through and do it all again, the corrected version, and I hadn't made a note of where any of the errors were. So I actually had to do this exercise myself. In fact, I had to do it twice now. So if it makes you feel any better, I've been through this pain. So I wouldn't ask you to do something I haven't had to do, quite literally. Okay, so I'll open up the rooms. Have fun, have a look, see what you think it's doing first, talk about as a group what you think it's doing, how it's supposed to be working, and then go through and see if you can fix this thing. Okay, let's go. Hello everyone, welcome back. So hopefully you found that fun. Certainly I didn't at all find that highly amusing in much the same way I did last year, as I bounced. It's always quite satisfying when I jumped into a few conversations where the elation of you actually getting the code working, or thinking you're working, at least running, and then realizing it still wasn't working in any way it remains entertaining. Yes, it was quite devious, and there were a few bits that I think quite a few of you got stuck on. I noticed some common elements. There was a line where you had the word dot add instead of dot append, which was throwing quite a few of you off for the list thing. So that was a bit devious as well. So yeah, it was hopefully this given you a bit of practice on being able to try and look through code and find where the errors are. And as you probably found, as you started to fix things, more errors started to appear because it was getting to points in the code that it hadn't got to before, and suddenly things were being changed and all sorts of new errors were emerging. But I did see at least one team that managed to get all the way through and fixed pretty much everything. A couple of minor things missed, but other than that, everything was picked up, which is really good. Yeah, hopefully that's been good practice. What I'm going to do, I'm going to give you in a moment the solution. I'm not going to read through it. What I'm going to do is just put you back into your groups and get you to have a look and just see what you picked up on and what you missed. And then once you've done that, then you can just sign off. But before I do that, are there any questions about anything we've done either from that or from any of the session today? Good, excellent. Now, the other thing I was just going to say as well, there will unfortunately at some point towards the end of the phase, the training phase, you will be set an assessment. The details for that will follow in due course. It's likely, I haven't fully confirmed it yet, but it's likely going to be on the day you've currently got reserved for the pitches. But I will confirm further details about that in due course. The key thing to say is that, first of all, don't worry about it. The assessment will be designed to be as light touch as possible. It won't be designed to catch you out in any way. It's not designed to try and distinguish who the best people are and who the worst people are. It's not that. It'll only be for people who are putting forward project proposals, so for project managers who are putting in project pitches. And it's only there just to check that if you're going to be taking forward a project to phase 2, that you've picked up enough of the basic Python skills to be able to do that. So the assessment will only be based on the 3 Python sessions that you just had. So today, last Tuesday, and the Tuesday before. There'll be nothing on anything beyond that, or even before that. It'll only be those 3 sessions, so that will help you understand the extent of what we'll be covering in that. And as I say, it will be as light touch as possible. It won't be, hopefully, it won't be difficult. It's just to make sure you picked up enough of the basic Python. The other thing I would say as well is that you'll get lots more practice before that point in using Python, because all of the methods we're about to show you, you'll be practicing all these skills that you've learned over the last 3 weeks, particularly debugging, I'm sure. And you will have lots of opportunity to keep practicing those things. But the key things of the Python basics we did in the first session around conditional logic and inputs and outputs and loops, for loops and while loops, and the stuff we did last week around functions and NumPy and pandas, and today around object-oriented programming and Matplotlib. That's the kind of stuff that will be in there. Nothing more than that. Just to sort of reassure you a little bit. I will also, in due course, I will post up the paper from last year. It's highly it will be much shorter than last year's one. So last year's was supposed to be an hour. I gave everyone an hour. Very few people actually completed it within an hour, and it was a little bit too long. So it won't be quite as bad as I don't think it was particularly complex. It was just a bit over long. So it will be shorter and simpler, hopefully, this year. But as I say, I will provide more details on that in due course. But don't worry, as you're going through this course, you'll naturally be kind of revising for this, because you will be practicing all these basic skills, and that's all it's going to test. Okay, so I'll put the solution up on the in the module 1 channel now. I'll open up the breakout rooms. Have a look through it as a team, see what you found, what you missed, and then once you're done, just sign off. Just a reminder, we've got another session this week on Thursday morning, which is on free and open source software development and version control. So the first half of that, I'm going to be talking to you about free and open source development and why that's important, and a bit of the history of that, and some of the principles of free and open source development. There'll be a little song in there as well, which you're welcome to join in with. And in the second half, I'll be talking about version control using Git. So do make sure you have Git installed ready. We won't be covering GitHub in this particular course, although obviously you are using GitHub in a limited capacity to grab your lecture materials. But the key thing is to get you using Git for version control of software. But there's lots of materials that I can direct you to within that session to make the step to using GitHub, which I'd encourage you all to do when you come onto your project work as well. And then next week on Tuesday, we will be starting basically the end of the introductory stuff, because over the last month I've been basically showing you all of the core concepts and tools. And then from next week, the fun starts, and it's where you actually start using all these new Python skills you have in order to start building models. So by the end of next Tuesday, you will all have built at least one discrete event simulation model. So you'll actually built something. And it was after that session that one of our HSMAs last year, our GP from North Devon, who'd never coded before, then set out on his journey to create the fantastic vaccination service modeling project that he did, and had that knocked up in time for Christmas. So just to give you a sense about the kind of the speed at which you're able to pick these things up, as I say, you're going to move from this basic stuff that you've been doing over the last few weeks to actually being able to apply this stuff very quickly. And hopefully you'll see, now that I've shown you all of the basics, when you come to next week and using SymPy, you'll find that it all slots into place. It's actually much easier now that you've got all those sort of basics under your belt. So that's next week. As I say, don't forget about the session on Thursday, which will be a nice fun session, free and open source and version control. And I'll put up the last bits now in the solutions. Go back into your groups and just have a check through, see what you missed. I think most of you did really well actually, and were sort of breaking things down and just got caught off on a couple bits. So see what you missed and make sure you understand that. And then otherwise, I will see you on Thursday. So have fun, and I'll post that.